Hey, Techno Studs! When it comes to encryption, symmetric key ciphers do the bulk of the work. So in this video, let's get into symmetric encryption. In this video, we're going to start out by talking about block versus stream ciphers. Then we're going to get into some examples, and we'll finish it off by talking about AES. So what we're going to be covering in this video is symmetric key, stream ciphers, and block ciphers. And when we say symmetric, remember what we're saying is that the keys to encrypt the message are the same as the keys to decrypt that message. So what is the difference between block versus stream ciphers? And it's just how many bits it's going to process at any given time. And I'm going to show you in the bits value because that's what's actually going to be happening on your computer. And so when we're talking about blocks, it's just how much are we doing in one go? How much in that chunk are we doing? And so you can see that it's got processed whatever chunk up here and some of the bits are missing. This is what it's working on now, and the next set would be down here, and it would do it in even amounts. Now how many bits it processes, how big these blocks are, is just going to depend on which cipher you're using and what the settings are for that cipher. So that is the block cipher versus a stream cipher is more as it comes. The idea behind it is as something streaming in, it can cipher it there on the spot. So usually we're talking about in a bit size or a byte size. I like to think of block ciphers as being used for things like files and things that are bigger. However, really, it just is used on a lot of different stuff, and it's the more common between block ciphers and stream ciphers. But how big is a block? Well, that's going to be determined by the cipher and its settings. And some ciphers have a set amount of bits that it uses, such as DES, a block size is 64 bits. And that actually started a precedent, so a lot of encryption ciphers actually use 64 bits for the block size. But there are some ciphers that are actually, you can set the block size and what the block size is going to be. Then you have a stream cipher. And I like to think about this as if you're streaming some sort of data, like maybe a movie or something, and as it's coming in or being sent out, it's being encrypted and decrypted at that point in time. Now, in reality, you could actually use this for a lot of different purposes, but that it would be a good use case for it is as things are going by, that's when it's encrypting. And that's why it's encrypting at a much smaller level, at the bit level or maybe at the byte level. So bit is the more typical one out of the two, and it encrypts a bit at a time. A few other differences between block and stream ciphers is that a stream cipher is called a digit. We do a digit at a time, and that could be, very commonly, that's 1 bit at a time, or maybe it's 1 byte at a time. But because this is such a smaller chunk of data, what it actually does is uses less memory. There's less to process at a time, so it uses less memory, and that makes it more efficient. Versus block can be easier to implement. And so one thing though about block is that if you have 32 bits and it's like DES that needs 64 bits, it does things in blocks of 64 bits, then it's going to need to add some padding. It's going to need to fill in those blanks before it encrypts that data. And this also can be used for streams. Blocks can actually be used for streams. 64 bits is actually not a lot of data, so it could be used, a block cipher could still be used for streaming. And it also can provide, block ciphers can provide other additional features such as integrity or authentication. So what are some examples of these? Well, as I mentioned, block ciphers are more common, and so there's a lot more of them. And stream ciphers, not as much. But DES, we've talked a lot about DES. Triple DES is another example we'll talk about here in a second. RC5, notice that RC5 and RC4, one's a stream cipher where the other one's a block cipher. Raindoll, and we'll talk more about Raindoll and AES here in a little bit. Blowfish and twofish, you'll also hear those terms out there. What we're going to mainly focus on is the ones that are starred here. So AES and DES are the ones that we're mainly going to be focused on. Let's take a little deeper dive into DES, which is that 56 bits effectively. It was adopted in 1976 and it was cracked in 1997. DES stands for Data Encryption Standard because it was the standard. It was created to be the standard and it was the most common one used out there. But when it was cracked, we needed an alternative. And so Triple DES came out as an alternative. And so what Triple DES does is it uses the DES algorithm, the DES cipher, to be able to encrypt things in a secure manner since DES was cracked. It uses 3 keys. So you'll see here key 1, key 2, and key 3. And so what it'll do is you will have your plain text and you'll enter it in, and that creates, and then it uses that DES algorithm, that DES cipher, to create your encrypted text using key 1. Then what happens, that gets put into a second iteration of this, but in this time it actually decrypts it, and it decrypts it with key 2. Well, when you decrypt something with a different key, it just mixes things up more and makes it that much more secure. So now we've got something that's really encrypted. And then we put it through a third time. We use the DES cipher again, but we use key 3. And now what comes out is something that should be more secure. And it was more secure for a while until we've decided now that DES and Triple DES is really not a secure method of encrypting stuff now. But that's how we dealt with the issue at the time. So how many bits? Well, what they would do is they take key 1, key 2, and key 3, all those bits, and they put them together to create one key. And so if DES is a 56 bits, because each one of these is going to be 56, that's what DES uses. So 56 plus 56 plus 56 equals 168 bits. So Triple DES used 168 bits. But there was one other variation, and that is you can actually reuse key 1 for step key 3 to make it a 112-bit key instead. So that would be just you're reusing that last key here. So that's 112 bits. So there's 2 selections there. You could use Triple DES at a 112-bit key or a Triple DES at a 168-bit key. Where DES is data encryption standard, AES is advanced encryption standard. So it's the next iteration, and it was adopted in 2001. So when advanced encryption standard came out, because DES was cracked and we needed a new standard, I like to think of it as a bit of a container. That is, we didn't have this container filled. There wasn't an algorithm that we specifically had in mind, just a need that we had in mind. And so we put it out there that we have this need, we need to create a standard, who wants to submit their proposals? And there were 15 entries that entered in and said, these are our proposals. From there was discussion and people talked about it, there was voting, and it narrowed down to 5 entries. And from those 5 entries, there's further discussion and narrowing it down, and then there was one winner. So Raindahl is the one that actually won through all of these. So when we say AES, it's actually the Raindahl cipher that we're using, but we will express it as AES because it's once again that container, that standard that we put out there and now is become the standard. AES is the new standard. AES is a block cipher. It does things in block sizes of 128 bits. The key sizes are 128, 192, and 256 for the bit sizes of the keys. And depending on which one it is, it goes through a number of multiple transformation rounds. So the 128 goes through 10 rounds, 192 goes through 12 rounds, 256 goes through 14 rounds. And that raises the question, well, what is a transformation round then? So let's take a look at a transformation round. You would have plain text, and then you would put it into the algorithm, and it would jumble it up and encrypt it where it comes out as a ciphertext. So this is ciphertext 1. And then you would put it into it again and it would go through round 2. And then it would come out with the ciphertext after that. And then you put it in there again and it would come into round 3 and so on and so forth. So 10 rounds for 128, 12 rounds at 192, and 14 rounds at 256. We started out in this video talking about block ciphers versus stream ciphers. We really focused more on block ciphers through most of this video because that's the more common one out of it. We gave some examples and then we took a little deeper dive into DES, triple DES, and AES.